So, you've just landed on the moon. What in the world do you do for an encore? Well, for NASA, the answer was something even more audacious. Build the world's very first reusable spacecraft. We're talking about a vehicle that could launch like a rocket, fly around in orbit like a spaceship, and then land back on Earth like an airplane. This is the incredible story of the secret playbook NASA used to tackle a challenge that honestly seemed downright impossible. All right, let's set the scene. It's the late 1960s. The Apollo program was, of course, this massive triumph, but it was also unbelievably expensive. I mean, think about it. We were basically building these magnificent rockets and then just throwing them away after one use. The future, everyone knew, had to be smarter. It had to be reusable. It had to be a true spaceplane. And this cartoon just perfectly captures the ambition, doesn't it? The goal wasn't just to get to space. It was to make it feel normal. As this fantastic drawing from a NASA employee shows, the dream was to fly back in style. The idea was to make a trip to orbit feel as routine as catching a commercial flight at the airport. But, behind that beautiful, optimistic dream was a brutal engineering reality. As one NASA director so perfectly put it, the job felt like wrestling a bull from the wrong end. The technical hurdles were just immense. And frankly, no one had a clear roadmap for how to even get started. So how do you even begin to solve an impossible problem like that? Well, NASA knew the answer wasn't going to be found in a single office or with a single genius engineer. No, they needed to tap into the brainpower of the entire country. They couldn't invent the shuttle alone. They had to orchestrate its invention. And their master strategy was to create a public-private partnership. You've got NASA, the public agency, acting as the conductor of this grand orchestra. And then you have the nation's top private aerospace firms as the musicians, all competing but also collaborating to create something incredible. And what an orchestra it was. I mean, we are talking about the absolute titans of the industry here. Rockwell, Lockheed, Boeing, you name it. NASA brought all these heavy hitters to the table, creating this amazing pressure cooker of competition and innovation, all focused on one thing: designing the shuttle. But here's the secret sauce. This wasn't just some chaotic free-for-all brainstorming session. Oh no, NASA put a brilliant, repeatable process in place, a kind of innovation engine that they just ran over and over again to turn this flood of raw ideas into a single, refined, workable design. And it was beautifully simple, really, but so powerful. It had 3 steps. First, knowledge generation. You let the private firms dream up and propose everything they can think of. Second, knowledge filtration. NASA steps in as the expert judge, sifting through it all and filtering out the weaker ideas. And third, the really clever part, knowledge combination. NASA would cherry-pick the absolute best features from all the surviving concepts and blend them into something new. Generate, filter, combine. That was the magic formula. So you can really think of it like this. The private companies, their job was to be the idea factories, just churning out designs from the wild and crazy to the super detailed. And NASA, they were the master architect, the ultimate systems integrator, with the final say on which bricks to use and exactly how to put them all together. This clear division of labor was absolutely the key to the whole thing. And you can see this process in action right here, in a real-world example from the project's Phase A. NASA looked at McDonnell Douglas's concept and said, okay, we like this fully reusable idea. Then they saw North American Rockwell's straight-wing design and said, that has better re-entry temperatures, let's keep that. They even kept the booster idea from General Dynamics. But Lockheed's concept? Nope, filtered out. You see, NASA wasn't just picking a single winner. They were harvesting the best bits and pieces from everyone. But just combining ideas wasn't enough. NASA had another trick up its sleeve. And honestly, this might be the most brilliant part of the whole playbook. When a truly game-changing idea showed up, they didn't just keep it. They amplified it. They made it the new foundation for everyone to build on. They called this knowledge reinforcing, and what that basically means is that NASA would spot a breakthrough from one team, and then for the next phase of the design process, they'd tell all the other teams, okay, everyone, this is the new starting point. Forget what you were doing before, now show us how you can make this idea even better. And if you want the perfect example of this in action, we have to talk about the story of the external fuel tank. It's a classic. So at the very beginning, almost every single design was based on the same logic. You had to build the gigantic fuel tanks for the orbiter's main engines inside the vehicle itself. But this made the orbiter just massive. It was incredibly heavy, unbelievably complex, and a nightmare to design. But then, one team, a partnership between Grumman and Boeing, had this total aha moment. They asked a simple question. What if you just took that huge, heavy tank and strapped it to the outside of the shuttle? It was a completely radical idea that went against what everyone else was thinking. NASA's engineers saw this, and they immediately knew. This was it. This was the game changer. An external tank could just be dropped once it was empty, making the orbiter way smaller, way lighter, and so much easier to bring home from orbit. So they did it. They filtered out all the old internal tank ideas and made the external tank the new standard for every single company. They reinforced the breakthrough. And the impact? Well, it was staggering. This one single reinforced idea is estimated to have saved over $1 billion in development costs. It was the system working perfectly, finding the absolute best idea and then making sure everyone was using it to move forward. Now, this whole incredible process of generating, filtering, combining, and reinforcing ideas wasn't just happening in some theoretical bubble. No, it was all driving towards a final design that absolutely had to work for its most important customer. And that customer was the Department of Defense. And let me tell you, the DoD came to the table with a list of demands that were totally non-negotiable. The payload bay had to be a massive 15 by 60 feet, and the shuttle had to be able to haul 65,000 pounds into orbit. Any design, no matter how clever or innovative, had to meet those specs, period. And this is why NASA's structured, disciplined process was so vital, you see. It took all of that amazing creative energy from all those companies and pointed it towards a very practical target. It ensured the final shuttle wasn't just a cool piece of engineering, but a capable workhorse that could actually do the job it was being designed for. When you look at the timeline, it's just incredible how fast this all happened. From the first call for ideas in late 1968 through all those phases of generating, combining, and reinforcing knowledge, like the external tank breakthrough in '71, it took less than 4 years of this intense managed innovation to lock in the final design of one of the most complex machines in human history. And this was the result, a truly versatile machine. It wasn't designed for just one mission like Apollo. It was designed for a whole new era of work in space. Things like repairing satellites, building space stations, and of course, carrying crews to and from orbit. It was the physical embodiment of this incredible collaborative process. So when you think about it, the space shuttle wasn't really invented in the traditional sense. It was managed into existence through this brilliant structured playbook of partnership and innovation. And that really makes you wonder, doesn't it? As we face our own modern moonshots, these huge challenges, from tackling climate change to developing safe AI, where else could we use a playbook for designing the impossible?